Hey guys, I'll be showing this problem using another kinematic formula. So, what I neglected to say in the last video is, I guess you're not interested in physics, but physics is amazing. Look at it. Look at my table right here. You can have 4 variables and 3 of them you know, and you can find the next one using one of these equations. How cool is that? Like when you're in a real world example and you don't know this last variable, who's gonna be crying now when you actually know all this stuff? See, physics is fun, but let me get back to the problem. So I'll be solving this problem using the last kinematic formula, and then I'll let you do what we always do. A rocket is traveling at 500 meters per second and speeds up to 700 meters per second in 100 meters. What's the rocket's acceleration from 500 meters per second to 700 meters per second? So what we always do is identify the variables. So it's traveling at 500 meters per second, so that'd be a velocity original velocity. And then it speeds up to 700 meters per second. That would be our velocity, final velocity. And then it gives you distance, which is pretty obvious right there with 100 meters. And it's asking for acceleration. You don't know time. Okay, let's go to our table. So we need to solve for acceleration. We don't know acceleration or time. The first one wouldn't work because we need to know, we need at least know acceleration or time. Second one wouldn't because we need to know acceleration or time. Third one, we don't need to know acceleration, but we need to at least know time. But we need to solve for acceleration, so you can't really use that one. The last one, you can solve for acceleration and don't know time. So let's use the last one. Yes, okay, that fit. Okay, now what we always do is plug in our variables and solve. Simple, right? So 700, that's a 7, just to say. Man, let me make that better. Equals velocity, oh, this could be a big number. Plus 2 d, which is 100. Okay, now let's simplify this. So we get our handy dandy calculator. Wow, this is gonna be a big number. So for 500 squared, do that mentally, but teachers want us to use calculators. 250,000 plus, I'll just do it right here, plus 200t, 200a, I mean. Okay, so let's wait. Actually, let me rewrite that. So it was $200. Okay, and we subtract this, so we want to isolate the a on the one side. Let's use our. Actually, I can do that mentally. So 240,000. And then divide that by 200. Then we get I can't see that. 1,200. And we can never have naked numbers, so we have got to put some codes on it, some labels. And there you have it. And then we always have to check our answer just to make sure, you know, if you have time, you can do this. Okay, so it's 502, that was 2. Okay, plus 200, wait. Yep, there you got it. It's 490,000. And there you have it. What did I say? Also, that with these equations, there's such a variety of things you can do with these. The kinematic equation. You'll be using these throughout AP Physics and things. The teacher will expect you. So it's actually really good to know how to use them. They're really simple. It's like 6th grade stuff. And just remember, it's like you're not doing it for like anyone. You're just doing it for yourself. So if you think this is stupid, well, it's actually really helpful. You'll use this in so many real life equations and stuff like that. Like when you're thinking like, oh, I need to know what time I have to get there. If I speed up from like 20 miles per hour, 40, and have acceleration rate of like 10 miles per hour, and then you can use one of these and got it. See, it's not that hard too, and you get pretty good results with all these four. There's such a variety of things that you can do with them that it's kind of hard to mess up. Well, thanks guys. I'll see you guys on the next video. So long. I'm Nick Cormai. Goodbye.